First, we've added a new laser that is 4 times more powerful, cutting print time by up to 50%. At the heart of the machine's precision and resolution is a new galvanometer control system that moves the laser more quickly and accurately than the previous generation. The redesigned peel mechanism is stronger and more durable, reducing wear for better reliability. And finally, our new injection molded resin tanks are now made with orange light-blocking acrylic, allowing you to store your unused resin outside the printer whenever necessary. Thanks to these new additions,
printer. The engineered plastic roll used in the SD300 Pro is both durable and economical, giving you attractive build cost per model. Second, insert the glue cartridge. Third, insert the anti-glue cassette. Finally, place the 3 anti-glue pens. Now just hit the build button on the provided SD View software and your printer is off. Finally, a 3D printer you can afford. The model is created by layers of engineered plastic. Following sheet lamination, the cutting knife goes to work directly from your CAD data. The engineered plastic roll is layered using special glue, resulting in strong yet flexible models. The anti-glue pens then apply masking fluid for easy support removal, allowing even the smallest details to be created, reducing development costs and time to market. Models are designed down to the smallest detail, and the engineered plastic roll is available in transparent or opaque colors. You now have your finished model in hand, ready for evaluation, without ever leaving the office.
The process begins when one layer of powder is added. This powder is then melted with a laser to form that cross-section of the 3D part. This process happens over and over again to create a 3D model. This machine can build one large part or thousands of small parts. These solid parts that have been melted by the laser, they are then surrounded by this unmelted powder. And the powder is more or less the mold that's holding those melted parts together. That combined with the thermal energy. So after the machine cools, you just wipe away the powder, and then you have solid part left. So in this case, the collar around the neck of the bird did not have to be assembled afterwards. There was just powder in between. As you can see, these parts are extremely strong and functional. You have flexibility and rigidity at the same time.
Five print heads, including black, increase color accuracy across the board and give us our first true black, while also providing color consistency from part to part. It's the best quality achievable in any 3D printer available on the market today. We responded to these needs by giving the Z Printer 650 an impressive 1200 cubic inch, nearly 20,000 cubic centimeter print volume, the largest build volume of any 3D printer on the market today, ensuring you always have the right amount of materials to complete the job. If supplies need replenishment, it's as easy as inserting new binder cartridges, connecting a powder canister for automatic loading, or snapping in a new print head. When ready, click Print and watch your 3D model emerge from the bottom up one cross-section at a time in 600 by 540 DPI resolution. When printing is complete, a vacuum and motion system automatically removes up to 80% of loose powder and recycles it for future use. Removing the remaining powder is just as easy, using lightly compressed air in an enclosed chamber that vacuums away particles as you go. Every 3D model emerges clean and ready for finishing. The Z Printer 650 comes with a convenient built-in finishing station for an integrated, all-in-one 3D printing system. Simply dip your part in Z-Bond sealant, followed by a short drying period. You get a smooth, vivid color model that lasts, and you get it fast. Best quality, biggest build volume, fastest print times. All in one machine.
Process that uses production-grade thermoplastic materials to produce both prototype and end-use parts. This technology is known to accurately produce feature details and has an excellent strength-to-weight ratio. FDM is ideal for concept models, functional prototypes, manufacturing aids, and low-volume end-use parts. The FDM process begins by slicing 3D CAD data into layers. The data is then transferred to a machine, which constructs the part layer by layer upon a build platform. Thin thread-like spools of thermoplastic and support material are used to create each cross-section of the part. Similar to a hot melt glue gun, uncoiled material is slowly extruded through dual heated nozzles. The extrusion nozzles precisely lay down both support and thermoplastic material upon the preceding layers. The extrusion nozzle continues to move in a horizontal XY plane while the build platform moves down, building the part layer by layer. The finished part is removed from the build platform and cleaned of its support material. Raw FDM parts have visible layer lines. However, service providers such as Solid Concepts offer multiple finishing options